Our learning habits are increasingly facilitated and simultaneously problematized by new digital tools. For instance, blended learning techniques facilitate an asynchronous learning culture, where students can learn autonomously at their own pace with online materials, leaving more classroom time for active learning activities that need real-time interaction and feedback. This study aims at designing active learning spaces that are instrumental to learners' self-actualization with the help of Metaverse tools. It defined Metaverse tools as digital technologies that enable us to interact and communicate in three-dimensional virtual spaces. And we're interested in how these tools may prompt systematic changes in our educational environment by breaking down the hierarchical divide between teachers and students in a classroom. By educational environment, we are referring to both the learning experience and the learning space, both soft and hard wares of learning that are reciprocal variables. In order to innovate learning experiences, we must first stand in the shoes of the learners. Similarly, successful spatial design must be driven by a participatory understanding of users' experience. Thus, Metaverse tools were used to create digital twins of educational environments that can be immersed and experienced from users' perspective. Traditionally, the design of learning space precedes the design of the learning process, causing the learning experience to be constrained by top-down spatial production. While top-down approaches can benefit the efficient implementation of a focused vision, it can sometimes generate generic designs that average the needs of the many and undermine the varying needs of individuals, especially in how learners can actualize themselves creatively in such spaces. To reverse engineer such modes of spatial production, this study invites teachers and students to collectively redesign learning spaces by first redesigning the learning experience. Cooperative design workshops were planned with the aim to help teachers and students in better understanding each other's needs and visions while learning to work together in a creative manner.
What are the engagement levels of different user groups in different co-design arrangements? What are the added values of immersive digital twins for educating and engaging participants in making more informed decisions collectively? How much was learned in the process, especially in understanding themselves as a community? The objectives are to engineer learning processes, understand the benefits and the limitations of real technologies in assisting the process, and evaluate how such forms of blended co-learning may be best utilized. The research hypothesized: 1. That the use of VR enables anonymous identities and license the power relations between teachers and students. 2. Better design outcomes using VR in the design process. 3. More insightful and diverse comments received using VR in the evaluation. And 4. Any correlation between 1, 2, and 3.
The co-design workshops are assisted by 3D modeling and virtual reality technologies. Participants were asked to collectively review existing learning space around the world, revitalize current lesson plans with active learning components driven by the chosen learning activities, design active learning spaces accordingly. Finally, the lesson plan will be simulated in a design virtual space, where teachers and students will evaluate the experience collectively or individually to compare the named or anonymous evaluation results. The project is contextualized in one of the most frequently used buildings on the CUHK campus, serving users from different departments, highlighting the interdisciplinary need for spatial design.
The building is reconstructed volumetrically using 3D scanning and modeling tools to compare different spatial typologies. The 3D models are taken as data input for VR engines to compare how it may affect learning experiences. Interactive peer exercise taken place in both physical and virtual environments, where participants help each other in understanding spatial designs and carrying out spatial analysis.
In summary, co-design is a participatory method that actively involves end users in collective design processes. First and foremost, it is a collective learning experience where designers, end users, and other stakeholders are treated as equals, in this case, teachers and students. They share expertise, experience, information, and skills with one another. In this study, teachers and students are invited to participate together, inverting the metrics of passive learning into a two-way communication experience, with Metaverse as an engagement tool to enhance interactivity and help users to understand spatial quality in an immersive manner.